Zombie apocalypse.
Okay, so today's discussion is reduction factor for beams and under flexure. So this will complete the principle as presented on the last video lecture that I have presented regarding analysis, rather the principle of a singly reinforced concrete beam. Actually, this will be also true until we, as we proceed with the next topics, okay, and onwards. So get ready to be neuralized. Okay, before we start, meron kasi tayong particular section in the code under 404.6 and then to be specific in 0.6.1, okay, here it is. So, design strength of a member and its joints and connection in terms of moment, ayan sinabi, moment, axial force, shear, torsion, and bearing shall be taken as a nominal strength. This is S sub n multiplied by the applicable strength, which is our interest for today's topic, the reduction factor. Again, let us have a short recall on my discussion regarding this. In USD, we need a larger stress, so therefore we need a larger force. And to maximize the stress, we need a smaller area. So for this to become smaller, we need an amount of reduction. Okay? Yan yung origin kung bakit tayo nagkaroon ng reduction na tatawagin natin as a nomenclature as phi. Yan yung function niya. Kasi dito sa load combination naman, yung tawag nating L sub LC, yung pang-magnify ng load. Okay? So therefore, kung moment ang ating interest, so we can say that the moment capacity, okay, should be equal to reduction factor phi times the nominal moment. The nominal moment is already discussed on how do we calculate that using stress-strain compatibility relationship. So to complete the idea, under USD, we need to calculate the phi value. So same as with 404.6.2 as stated here. So greater than or equal to the required strength you calculated to the factored loads and forces in such combination as required by this section. Kasi we can say that of course, the capacity should be more than the maximum, say M sub A. So this is taken from the load, okay, or let's say actual, meaning this is the computation of the maximum moment taken on the beam, while MU is taken as a capacity. So for us to say that the section is safe, then capacity should be always more than the actual. Now, let's proceed with section 421. No? Andito yung mga codes natin. Okay, so sinabi din ng 421.2.2, yung sinabi nung kanina, no? Similar lang, pinaikse. But meron kasi dito na table 421.2.2 na sinasabi. Okay, so let us have the general idea muna. So the strength reduction factors dependent on the idea. Sabi na natin kanina, may pang moment, may pang shear, may pang torsion, may pang bearing. So iba-iba yung value. I want you to investigate letter A. No, sabi diyan, for the moment, axial force or combined moment and axial force, it is said to be 0.65 to 0.9, meaning it can be equal to 0.65, it can be equal to 0.9, or it can be somewhere in between. So, meron tayo i-generate na value for moment. No? For shear alone, we need 0.75. For torsion alone, that is 0.75. Usually, the shear and torsion are equal kasi the product of shear is torsion. Yung nagiging irregularities no ating application of the load may produce sudden twisting to the beam. For the bearing, we use 0.65 and etc. So, yan. But today's focus will be on letter A. So, ito ang ating magiging highlight of the discussion. Okay? So, how to treat the reduction factor phi in understanding flexural capability to resist load under, of course, for the beam. Of course, in 421.2.2, let me show you this. Kung mapasin mo ito, yung tatlong yan, mayroon tong relation but not derived na ganyan. But I want you to focus that there are three terms to identify. First is what we call compression controlled. The second one is tension controlled. And the other side is the transition zone. Okay? So, let me define what is tension controlled. Tension controlled, usually, the action should be under beam type or flexural ang nangyayari. Okay? Flexure ang kanyang main movement. For compression controlled, usually ito may titawag nating column type. Okay? O yung titawag nating compression. Yan, sinabi na. Compression members. Usually, ang beam naman, kilala natin under flexure kasi the loads are gravity. So, it will deflect towards Earth. So, therefore, there will be some deflection ongoing. While column, subjected for gravitational load, so it will compress the member. So, what will happen is under compression. So, usually, ganyan nangyayari. So, pero yung beam natin, maging mukhang column ang action kasi yung sa axial force resistance eh. Okay? So, sa axial force resistance, hindi siya significant. Kumbaga, very significant na siya. So, imbis na mag-deflect ng ganyan lang, so, nagkakaroon pa dito ng malaking, say, compression value delta. Iba pa itong delta na ito, say, delta na, na deflection. Okay? So, delta becomes significant sa pagka nagkakaroon ka ng condition na yan. Okay? So, pagka tension control, delta naman na deflection yung bida. So, in delta, relates to being a beam, and compression deformation, or what we call the deformation under lateral, ayan naman po yung kontrolado ng compression member or compression control. Pero minsan kasi ang action ng beam, there's what we call beam column. Okay? Pag sinabi nating beam column, the action of the beam, we're talking about the beam, is governing either compression and and flexure. So meaning the beam is capable to behave like a beam and a column. So to simply say that. So formulas are presented here, but I want you to understand how this formula is being generated. Kasi pag ito na-generate natin yung under other, kasi malinaw dito, under this table, the first table relates to having a condition of spiral. So other than being spiral is other. So which is a beam falls under the other condition. So we need to identify and prove what are these formulas and how do we derive that. So notice kapag compression controlled, we are using 0.65. For tension controlled, we are using 0.9. And if transition zone, then we try to compute this formula. Use this formula. For others. Okay? Sa beam kasi, hindi mo na tayo maglalagay na, or walang ilalagay tayong spiral, kasi usually sa column yan. Okay? But if you will notice, meron tayong tinatawag na E sub Ty. So, ito yung value na sa code natin na 0.002 ay yung under yielding maximum strain. Ayan. So, sinabi ng code na yan. So, let me erase this para mas ma-visualize. Okay? So, sinabi ng code na yan is for deformed reinforcement, E sub Ty shall be Fi over Es. So, for grade 280, deformed reinforcement, it shall be permitted to take the maximum tensile strength under yielding equal to 0.002. So, again, that E sub Ty is 0.002. So, ibig sabihin, hindi pa simplified yung formulation natin. You need to understand that you need to supply it first for you to see the full version of the equation. So, kapag na-simplify niyo yan, lalabas na 0.002 over 0.005 of minus 0.02 is just 0.003. So, nasa denominator yan. And numerator is 0.25. Meaning, 0.25 over 0.003 is most likely becomes 250 over 3. So, therefore, the other phase would be like 0.65 plus 1/4. Kasi 0.25 is 1/4 quantity of E sub T. Sorry, it's not 1/4 kasi ang 1/4 is just the exterior value. Okay? So for that value to exist. So, let me take a look, no, 0.00. Yes, ito na, no. It's 250 over 3. Okay? Kasi nga 1/4 over, or 0.25 over 0.00 is already 250 over 3. Okay? Minus 0.002. Tanong, how did that formula is being generated? So, let's take a closer look. Let's try to unveil what does the formula suggest to us, and how does it being generated as a formula like that. So, as mentioned earlier, so there's what we call compression controlled as a column and tension controlled as a true beam. So, the effective depth D is measured from the compressive fiber to the centroid of the longitudinal reinforcement. This is already explained. But I want you to notice that there's another definition like the D sub T. Okay, this is different. Which is the measurement from the extreme compression fiber to the extreme layer of the tension reinforcement, or simply say the nearest layer of the reinforcement it should be explained as the nearest layer of the tension reinforcement to the nearest tension fiber of concrete, okay, as shown on the figure that I will show later. So another thing is that we have the E sub T, or the strain at the tension, the maximum tension controlled system, or the strain on the maximum stress or maximum strain of the steel, sorry. So it's defined as the net strain at the extreme layer of reinforcement at nominal strain condition. Very important to understand that nominal, so meaning we need to understand the strain relationship. So in figure, ito po yung magiging itsura niya. So, kung naalala po ninyo, yung effective depth D is the rebar center, as explained already in one of my past video lecture. But the D sub T is taken as the last layer reinforcement, okay, up to the nearest, up to the compression fiber of concrete extreme, no? Extreme compression fiber of concrete, okay? So, yung sinasabi ko kanina, ito yung layer of reinforcement na pinakamalapit naman sa tension fiber of concrete, okay? Extreme, sabihin na natin extreme tension fiber of concrete. So, meaning, the D sub T is always measured from the compression fiber of concrete extreme up to the last layer of reinforcement that is nearest to the extreme tension fiber of concrete para tayo mahirapan. So, when can be D is equal to D sub T? Kapag single layer reinforcement, no? This is only true for single layer kasi nangyari one layer lang, para yung mga diniscuss natin nung past discussions, okay? But if D will now be less than D sub T, ito ba tinatawag natin yung multiple layer, so more than single. Kasi pwede po multi-layer yung ating reinforcement under tension. Okay? So, in the code, sinabi na ang code is 0.03 extreme compression strain. And kung may E sub S ka, mayroong E sub T na rin. So, E sub T is related to D sub T, and E sub S is related to E sa D. Okay? Sa D. So, how do we use this? Okay. So, nakikita niyo po dito yung relation. Okay? May sinabi po yung code kanina, tension controlled system, the understanding should be the strain is 0.005. Okay? For tension controlled. Kapag compression controlled, set mo sa E sub T as 0.002 for compression controlled. Okay? So, let me write this. Pag tension control limit, we need to use that E sub T, or the maximum tension strain of steel is 0.005. We need to set that by the code. And for the compression, okay, let me write CCL as a shortcut. CCL means compression control limit. So that is E sub T, set it to 0.002. Those values are already proven by testing. So, laboratorical value na yan. Sige, paano yung gamit niyan? So, ganito gagawin. Derive muna natin yung simpleng equation niya. So, using this similar triangle, let's say this is theta, this is theta. So, sabihin na natin, function muna ng E sub T tsaka ng 0.003, ano? So, don't forget that this is again small c, and this is D sub T minus c. So, by relation, by triangle relationship, 0.003, no? As to c equals E sub T, really as, straightforward value, then dt minus c. So, gagawin nyo lang po, ilipat ito dito, ilipat po dyan. So, what do we get? So, 0.003, tapos i-expand ko na. So, d sub t minus 0.003 of c equals e sub t times c. And then, our main agenda kasi dito is c as a function of d sub t. So, mangyayari is, ilalagay ko po ito dito. Okay, pwede naman ganyan. So, meaning, that would become c is equal to 0.003, okay, as to, syempre, di-divide naman natin later, e sub t plus 0.00, but what 0.003? Yes, 0.003 kasi strain of concrete. Okay? Times, okay, times d sub t. Okay? So, ngayon, susuplayan natin ang value to. Okay? Na meron kang dalawang generated condition. Na pwede kang gumamit ng 0.005. Pwede kang gumamit ng 0.002. Pag 0.005, ito po yung tension control limit. At kapag 0.002, siya yung compression control limit. So, pag ginamit natin, ito po yung mga lalabas. Sa C as a tension control limit is 3/8 kasi matatanggal yung decimal. I assume that the learners or viewers are already aware of some simplified calculations. Okay, they do already know how to derive these things. So, yung 0.003 over 0.005 is 3 over 5 lang din naman. Parang ganyan sense. So, again, 0.005 plus 0.003 is 0.008 or simply 8 kasi natatanggal yung decimal relationship nila. Kasi same lang naman ng scientific notation, kumbaga. So, the 3 over 8 of the d sub t for the compression control limit is 3p4.6. So, this is very important, no? Ibig sabihin po, kapag tension control, it's all about 37.5% ng ating d sub t or the distance of the last layer reinforcement nearest to the tension fiber concrete up to the extreme fiber concrete. So, pagka compression control, ibig sabihin, 60% naman yung ginagamit na distansya ng d sub t. Okay? So, how do we use these two? So, dito na po magsisimula kapag hindi siya nag-fall under ng tension control limit at saka compression control limit. Ulitin ko, kapag tension control limit, so sinabi po kanina ng code natin, kung maalala lang po ninyo, na kapag compression control limit, automatic po ang fee natin yan is 0.65 based on the table as presented earlier. Kapag tension control limit, it's automatic to use 0.9. Okay? So, kailan po yung nag-activate? So, pag CCL, ulitin ko lang po, kapag ang nakuha nating strain is less than 0.002. Okay? Nag-activate po ang tension control limit kapag ang maximum tensile strain is more than, sorry, it's not equal, but let's say more than, para at least meron tayo, more than, okay? 0.005. Okay? So, yan po yung kondisyones. Okay, pwede natin gawing equal. Siyempre, pwede naman ganyan. Okay? Pero, kapag wala dyan sa dalawang condition, sabihin, in between 0.002 and 0.005 nakuha, dyan po papasok yung transition zone. Okay? Pag sinabi natin transition zone, a section that has a tension reinforcement area such that when the beam reaches its nominal flexure strength and the net tensile strain in the extreme layer of tensile steel E sub t is in between 0.002 and 0.005. Yan po yung sinasabi ko kanina na in between. So, we will call it transition controlled system. Okay? So, pwedeng tawagin, transition zone na lang. Pangalan nating transition zone. Or should I say TZ? Okay. How do we calculate? Sinabi ng code is it can be derived linearly. Kung mababasa nyo po kayo na sa isang mga table. So, therefore, deriving it linearly, ganito po ang kalalabasan. Yan. Okay. So, under tension control system, a value of 0.005. Pero kung tignan mo yung C over dt niya, under tension control system, kapag nag-fee of, nag-E sub t ka ng 0.005, ito makakuha mo, 375 of C over dt. So, ang gagawin nyo lang po, i-divide nyo lang dito. Okay? C over dt. Okay, malinaw po yan. So, and then, kapag compression control, 0.65, 0.602 equivalent na E sub T niya, at saka 0.6 naman C over DT ang kanyang relation. What I want you to notice that, mas malaki yung 0.6 sa 0.375. So, therefore, I can make some good relations. What if I get the inverse? So, I'll get later 0.6 and I'll take the reverse of 1 over 0.375. So, ito, mangyayari, this should become 1 over C over dt, okay? Or should I say dt over C? Okay, so mangyari po ganito. Somewhere here is the location of the phi. We don't know right now. Okay, so there should be a trace of phi. So, let's say nandito. Okay, so ignore nyo muna po yung 75, ano? Kasi hindi naman siya part ng analysis kasi for spiral yan. So therefore, meron kang trace dito. May tatamaan yan. So, tawagin natin E sub T yan. Pwedeng, siyempre, in relation to E sub T and in relation to C over dt. Okay? So, how do we derive that? Ayan na po, pinakita. So, using similar triangle lang naman po yan. So, may triangle ka nakikita. Ayan. Dalawang triangle of similar angle, say theta. So, again, to relate in terms of relationship of phi and E sub T. So, phi, I'll just try to highlight a little para makita. Okay? So, ito po siya, no? Phi, tapos tatakbo dito. Yan yung value na yan. May trace po yan. Ayan. Okay. So, therefore, that would become this one. Okay? Yan po yung mangyari sa kanya. So, therefore, by relation, what will happen is phi times 0.65 over 0.9 minus 0.65. Parang nagamit lang ako ng relation ng triangle. So, parang ganito po siya. Ayan. So, parang binawas-bawas ko. So, therefore, meron kaya yung relation dito na 0.9 minus 0.65. Okay? So, sa baba, yung sabihin na natin na extreme limit of 0.005 minus 0.002. Okay? Tapos, this one is phi minus 0.65. Tapos ito, this is just E sub T, the unknown value, minus 0.002. So that's why I arrived to this. And then finally, upon derivation, you will identify 1/4 over 0.603, or also known as 250 over 3. So therefore, ito yung katulad ng pinasent ng code kanina. So this is the computation of phi under transition zone. So, the value expected by the value of phi should be in between, kapag transition zone po, is in between 0.65, okay, also not to exceed 0.9, okay. So, ganun din po. Pero paano pag si over dt kukunin ko? So, what I take is this. So, sinabi ko kanina na i-take ko na lang yung inverse kasi negative yung lalabas niyan. So, pati yung value na nito, i-inverse ko na rin, no? Yung 1 over c over dt. Ayan, as presented here. So, therefore, by taking a closer look, by derivation, 0.8 minus 0.65 is just 1/4. And then 1 over c over dt minus 5/3, of course. No? Makikita naman po sa calculation yan. So, what will happen is, I can now generate my next set of equation where I can say, as a function of dt over c or c over dt is 0.65 plus 0.25 or 1/4 of dt over c, or you can say 1 over c over dt minus 5/3. So, either of these two will give you the same answer of phi. Okay? So, ano advantage nung una? Usually, kinukuha kasi natin to madali natin makukuha itong formula na to. Pero pag nagdi-design, usually ito maganda ito for investigation. Okay? Investigation purposes. But usually kasi pag nagdi-design, wala ka pang dimension. May target design performance ka. So, I would like to recommend this under design. O yung may nawawalang dimension na we need to understand how much or how high is the beam. Parang ganun. Okay? Kasi may target si ka So, therefore, yan yung aking mga recommendation. But, you can use both para to investigate if you will get the same answer. So that's it. Thanks for viewing. And next video lecture is I will now try to show you some sample problems. One showing a rectangular concrete beam and other is the irregular section so that you would know how to treat them separately. So by this, as a tradition, You have been neurorized and see you in our next video lecture.